Welcome to Exploration Radio. I'm your host Ahmad. Continuing on with our interest in space exploration, our guest today is Angel Abbud-Madrid. Welcome to the show, Angel.
How are you, Ahmed?
So we wanted to talk to you because your title is Director of the Center of Space Resources at the Colorado School of Mines. And your main role is to lead research into the human and robotic exploration and utilization of resources in space.
That is correct, yes.
Let's start off with a little bit about your background. You're an engineer?
Yes, I'm originally from Mexico, and there I went to school to get mechanical and electrical engineering. My first job, interestingly enough, was on a gold and silver mine on the northern Sierras of Mexico. These were very isolated places back then. That I got the first chance to learn about mining, about geology, things like didn't directly apply to what I actually studied, but it was my first opportunity. And so I worked there for a year and a half, never thinking that I was going to use this type of knowledge again. It just turned out that I actually use it now, but to mine not on Earth, but beyond that.
So did you have a desire to get into the mining industry or the extractive industries at all?
No, actually, my interest was all along on space. I mean, I grew up during the space era, the Apollo years, and where the only opportunities there was either you were in the United States or the Soviet Union. Yeah. Anywhere else, it was really hard, especially Mexico. So I thought maybe if I studied something related to this, it will be applicable. And so I decided, okay, I'll cover mechanical and electrical. Maybe that will be used. And it helped me later on. It was not until graduate school that when I went to the United States, that I actually got involved in space-related work.
Because you did a degree in aerospace or aeronautical as well?
Yeah, my master's degree was aerospace and mechanical at the same time. So that's when I started getting involved in the aerospace world.
So the interest in space was really from the fact that you wanted to have some role to play in the industry, I assume? Is that really the interest?
Yeah, my interest was obviously when you're a kid, and I was 8 years old when we got to the moon. Yeah. You always want to be an astronaut, but as I grew older and I started studying, I learned that I could be involved in so many ways. I mean, the space program involves thousands of people that are working in different things. So I said, well, if I can work on an experiment, I can work on developing hardware that can be utilized in space, I will be the happiest guy. And I got the opportunity to do that right after, during my graduate studies, I got involved in work in what's called microgravity. So you do experiments on airplanes and things like this. But then I had a chance to work on Space Shuttle experiments and International Space Station experiments. So
yeah, wow. So where does the fascination of resources in space come from?
When I moved to Colorado School of Mines in the late 1990s, I went there because they were doing their first space experiment. It didn't have anything to do with mining. It has to do with fire suppression. But while I was there, a gentleman came to School of Mines. He left NASA. He retired. He was one of the pioneers on space resources. His name is Mike Duke. And so he came to the School of Mines, knowing that at Mines we had been doing some preliminary work on space resources since the beginning of the space program in the 1960s. The School of Mines was one of the first ones that thought that having all the expertise in terrestrial resources could be applied at some point in space. So there were different faculty involved in the 60s, 70s, 80s. And then in the 90s, this gentleman came along and he said that, he wanted to retire in Colorado. But he thought that the School of Mines had all the ingredients to start looking at resources beyond Earth. And that's when I first heard about it, and I got involved more and more in projects, and we decided to create the Center for Space Resources. When these gentlemen left, Mike Duke left in 2006, I then became the director of it. And it was at the time that also there were more and more projects related to space mining, space manufacturing, everything related to resources. And that's how I got really involved. And that's when my previous experience on mining gold and silver on Earth started actually applying to the new field of space.
Right at the start, on a very basic level, what similarities do you see between, say, the exploration and extraction of resources on Earth, as well as, say, exploration and exploitation of resources in space? Are they on a fundamental level, are there some similarities?
Yes, the same materials that we have on Earth, you have it on the moon, Mars, and everywhere in the solar system. We are all made of the same stuff. The difference is the different type of environments. So when you mine, we have had hundreds of years of experience of mining on Earth. And we've been doing it in a way that we know already, for example, the gravity level in which we work. That's the only one we know. We know the environment, our temperature, our pressure. We know one thing that we have been very successful at doing is because we have plenty of labor and power. But when you start looking at you're going to do the same thing on the moon or Mars, all of these things are going to be different. So you're going to have to adjust your equipment to different gravity levels. All of a sudden, you're at 1/6 level on the moon, 1/3 on Mars. Extreme temperatures, much colder, very sudden changes. You're working on a vacuum. All of a sudden, there's no atmosphere, so it's different. There's no labor. And so you're going to have to start thinking automation and remote control. It depends where you are. Power, you're going to have to adjust to whatever is there. So it's solar power, probably nuclear at some point. But so you're just adapting systems. And so many systems look similar to what you will do on Earth. But the other thing to consider is that when you send things to space, since it's so difficult, it's so energy intensive, you have to be very aware of the how much mass you're sending, the volume, the power. Everything's going to be quite reduced. And so learn from what you've done on Earth, but some of the things are going to be completely new. For example, if you're mining asteroids, there's no gravity. And so all of a sudden, excavators or drilling systems, nothing stays on the surface. You have to anchor yourself. So you come up with techniques in which you can extract like the water and things like this from remotely. These different techniques that are called optical mining. You use the concentrate solar rays to do it remotely and not actually physically on the body.
In a way, if you look at our kind of industry on Earth right now, we have somewhat handled these problems before. Like we work in really remote areas, we work in really challenging areas, either geographies or climates, etc. So it's not in that sense a unknown problem. We have solved those problems on Earth. I guess like your point, which you've made, which is a really valid one, is that in space, there are different parameters in the environment that we will then have to navigate. Would that be a fair way to say it?
Absolutely. And that is why, whereas the first 60 years of space exploration has been about rockets and probes to places far away, now that we're looking at using space resources, that's when we go to the mining industry. We go to the oil and gas industry and the equipment manufacturers because they are the ones that have the experience. Space agencies know about rockets, but they don't know about extracting resources. So that's where the mining industry comes in because they've been doing it for quite some time. And that is the reason I'm here in Australia, because Australia has, first of all, long history in terms of extracting resources, recent history and quite an expertise on automation. The most advanced autonomous operations are conducted here in actually in Western Australia. And so we've been trying to reach out to them to tell us how they tackle things like this. And their interest is in, if you are to develop systems that require complete automation to operate in extreme environments, any design that you do there, it's of interest also for their operations here. It goes both ways. So we're going to be intersecting a lot in terms of our needs, which, like I said, it requires extreme environments. So the same type of rover that you would use on the moon, completely autonomous on very extreme environments, you can use it on an operation here.
I mean, I think that's a really important point, is that not only is it the technology side of the industry, like you said, like we're working in harsher and harsher environments, we're dealing with more and more remote locations. So, and automation will play a role. Mining companies are talking about automation. On space, you're probably going to be like one end member of the automation spectrum, where it probably has to be fully automated, can have very little involvement with people, or if any at all. But even from the point of view of the science of how to explore, we're becoming more about remote sensing and trying to find non-invasive methods to try to find deposits before we put the money. So there is this kind of natural intersection of these two, the science and the technology. It's just that the space exploration will probably be the really end member product where we'll take it as far as we can.
And in fact, a lot can be learned. It's not just the operations. You mentioned the exploration side of things, the prospecting side. We need to characterize the resources first before we actually go and do it. And so the mining industry is quite experienced in all sorts of high-tech ways to look at how deep is the deposit, how widely spread, what is the concentration. We need to know all that even before we attempt to use any technologies to extract them. So a lot of that will be the same, what's called the geophysical method to do this. They will be used, actually they're even being used right now from satellites doing remote sensing on Mars and asteroids on the moon. It's the same thing that we use here. It's just they're looking for probably a different type of... Because the geology of... This is an important thing to understand. We're so used too used to the geology of Earth and the processes that have shaped our planet, those are different from the moon. I mean, if you look at the moon, there's no wind or oceans, there's no water. So a lot of the surface of the moon has stayed like that for quite some time, but they have other methods in which the surface changes. They're hit by asteroids and by micrometeorites. They're hit by solar winds. So these are different processes, and we have to understand them.
But I think one of the points that you make, which I really like, is that there is this perception, I'm not sure if it's right or not, but the perception is that space exploration is like a pipe dream. It's the concept of science fiction, like, you know, we're going to be doing this like way in the future, et cetera, et cetera. But in reality, if you think like from a philosophical point of view, that you said the skills exchange, stuff that we do for space exploration will actually have an impact on what we do on Earth as well. The concept of automation, like, you know, obviously we're not going to have to tackle the gravity problem, but that automation system can be used here. Techniques of remote sensing can be used here. So it's not like, you know, it's not that far a leap of faith if you really think about it.
No, yeah, you're right. And the thing is, we think about, obviously, you know, we're separated from the space by our atmosphere, and we all live here in a cocoon, right? So the environment of space is quite harsh. But more and more, we depend so much in space that we don't even think about it. In fact, the very first resource that we have utilized from space is just the view from above. It was communication satellites in the early 1960s that utilized that resource. And look what it has given us, you know, weather forecasting, global communications, GPS systems that you use on your phone to go anywhere you want. It has given us that ability to see what changes we're causing on Earth as we extract resources and look for energy sources here on Earth. So that's quite a resource. And then you have solar energy and you have microgravity, vacuum. These are what we call intangible resources. You don't mind this, you use them. But we are so inextricably tied to space now that if you suspend all the activities in space, you bring civilization to its knees, literally, everywhere.
Yeah, that's right. I mean, just something simple like the communication aspect that you talk about, right? Like, I mean, we are a society built on communication now. So if you take that away, I mean, you will probably rip the social fabric that we've kind of built up over the last couple of decades anyways.
And one thing that is important to understand is that we're not doing this because you're saying, you know, science fiction and do resources in space. It's born out of necessity. The same way that humans started moving around the planet looking for different resources and that will allow them to not just explore but also to live in other places is the same reason why we have reached this point. The space program, 60 years old, we have done a lot of scientific discoveries, but we have reached a point in which we need to go to the next step. And we are right now hindered by transportation. It's extremely expensive. And that's why only a few countries can afford to do it. Only a few human beings have gone up there. But if you can lower the transportation costs, it will open up all sorts of activities. And how do you do that? By not bringing everything from Earth. Right now, if you want to go to the moon, or you're going to go to Mars, you're going to have the fuel to get out of the planet, to go all the way to Mars, to decelerate in Mars, to live there for a year and a half, to all the fuel to come back, to decelerate. So that's lots of rockets. It's extremely expensive. So why not use the fuel that you can get from hydrogen and oxygen that you can get from water on the moon, Mars, use the one that you have over there, and now it starts making sense. Here on Earth, we don't carry everything with us. We use resources as we go. Same thing is going to happen. So resources are not a destination. There are means to enable to explore us further, eventually to stay longer on planetary bodies, and that will bring along more commercial interest, given access to more countries, more people, and so you're using that to open up space even more than we have right now.
So we talk about resources in space. Is there a difference in what we perceive to be resources in space versus what we perceive for them to be here? Is the definition of resources different when we look at space in that sense?
The definition is not. A resource has value because of its utilization. So if you're just looking to identify elements in space, well, that's out of scientific curiosity. Or when you talk resources, it's because you're going to use them. And so that's the same here on Earth, on Mars, exoplanets, wherever it is. So you're looking for elements that are going to be useful to you. And so from that point of view, that doesn't change. What may change is that some resources, we tend to think about resources here on Earth as concrete things, metals, minerals.
Right, as commodities essentially, right, to some degrees.
But for example, when you go out into space, anything that can be useful, you have to be very resourceful because you're in a rough environment. Yeah. So it could be solar energy, and that will you can power a spacecraft. It could be low gravity that you can use to make certain products that you can not do here. You have ultra high vacuum that is really hard to get here on Earth. Then you have the concrete ones. You have the minerals and the gases and the water. But for example, for us in space, a very important resource is water. And water is important here to survive, but you don't think about mining water. I mean, it's a different way.
Yeah, we're a little bit spoiled for the fact that we have a lot of it around.
It's a lot of water, that's right. Yeah, but over there, you're going to have to go out to very unique places, very dark, permanently shallow regions on the moon, just to get ice that then becomes extremely valuable because you can split it into hydrogen and oxygen, and all of a sudden you have the most energetic propellant that you can use for rockets that you don't have to carry from Earth. And this is a very important point here. Getting out of Earth is very energy intensive. You look at any rocket, 90% of that big rocket you see there is fuel to get you out. And you're lucky if you can send 2 or 4% of the weight out into space. So that is because of big gravity level. In fact, if Earth had been just half more of its diameter larger, we will never escape it. With all the chemical propellants, we will never be able to escape. We were given just a very slight opportunity to get out of our planet. But whereas if you go from the moon, it's much easier, or asteroids, because you don't need any energy. So that's the big reason that we want to extract the resources somewhere else, because bringing it from Earth is just too expensive, it's unsustainable, it's too inefficient. It's just that the only way that we know now, but if we can use something else, why not?
So the concept of like us funding or us supporting space exploration from Earth is fundamentally not an economic proposition.
Up to this point, it has been just taxpayers that have been paying for the space program. And what we have gotten in return is just fantastic information about space. There's a commercial aspect. In fact, I mentioned that one of the resources is just location or the view from above. Not only is the only resource that we have used, but it's the only commercial use of it. It's a $350 billion a year industry just in communication satellites, GPS, all of those things that we use right here. That's the status of us, how much is commercial, how much is the private sector. So we're looking at ways to increase participation of the space sector by using resources. Because if now you think about it, yes, we have communication satellites. They run on fuel, and once they run out of fuel, that's it. It's over. You have to get rid of them. What if and then when we send anything to space, you send one rocket, that rocket deploys the satellite, and then it's gone. Mm-hmm. So if you could refuel those rockets, you can have fuel depots in space. They can refuel and they keep moving. You can refuel satellites so they can live longer, or you can move them around. So all of a sudden, you're opening up a whole new way of doing things in space that you have not done before. And so it's just it's a way to enable not just more exploration, but more commercial activities.
So what was the interest behind putting together the program at the Colorado School of Mines? Because I think you guys are probably the only university that has this comprehensive a program.
Yeah, an academic program. That is correct. I mean, I mentioned that School of Mines was involved on research since the very beginning of the space age. We participated in some of the very first meetings in the 1960s on looking at resources in space. We created the Center for Space Resources 20 years ago as pretty much the first research center in a university to look specifically at space resources. At the same year, we created the Space Resources Roundtable, which is the premier meeting on this area, which back then were about 20 or so people only that gathered. This year, we have more than 200 people that are from all over the world.
So what was a tipping point? Well, like, when did that become like more part of the social dialogue?
It went through stages. When we started, it was for us just a way to look at how else we could apply the expertise of the school, which for 145 years has been focused on terrestrial resources. We thought at some point we're going to need to be ready for the next stage. And so we started doing work on very basic things. Actually, the very first studies were economic studies. Does it really make sense to bring resources to Earth? Or is it about using the resources in space? So that gave us some of the very first ideas of what we should be pursuing. Then in the 2000s, there was a push by the United States to go back to the moon. That was under the second Bush president. He was pushing for having humans there for several weeks or months. And so it was about obtaining oxygen that they could use. So we got involved in research on how to extract oxygen and excavation systems and the like. And so we saw the steady growth in the interest. Then it was about asteroids later on. But it was not until 6 or 7 years ago that the first private companies started appearing talking about asteroid mining. They were talking about going to the asteroids and mining platinum and bringing it back to Earth, which...
I mean, some of those stories are fantastic. Like, going and grabbing an asteroid and like towing it back to Earth or whatever.
That's right. Studies that we have done in the past just didn't make an economic case for that. And that's how these companies started, with a lot of money. Eventually, they started changing their business case to more things that we always thought were probably better, like water. And at the same time, more companies started coming along. Other countries started showing up in our meetings. So we started seeing an increased interest on this. Internationally, private sector and the public sector. Companies also, a country like Luxembourg 3 years ago or 4 years ago, started talking about doing the same thing, putting money into this. Companies, transportation companies like United Launch Alliance started becoming some of the first customers when they announced that they could purchase propellant. They don't care if it comes from the moon or asteroids, as long as you can lower the price of propellant in space. So once we started seeing all this rise in interest in the last few years, that's when we decided, and we've been toying with the idea, at some point we would like to have the academic component, not just the research, studies on this. And so 2 years ago, we decided it was the right time to start educating those professionals that were going to be involved in the first projects, because we saw there was a lot of misconceptions about terminology, what can be done, what was real, what was hype, what can be done. And so 2 years ago, we decided to launch the very first program in the world focused on space resources to educate scientists, engineers, economists, policy analysts. This is a very multidisciplinary field.
This is the point I was trying to get to, is that I think the really interesting thing that I find about the program that you created is that in a lot of ways, it's really the amalgamation of all the issues that you have in the aspect of terrestrial mining, right? It's like the social aspect, the economic aspect, the engineering aspect, the science aspect, all of the... And what I find really interesting is that obviously you're creating a program for space resources or space mining, and yet it's the only program that kind of accounts for all these myriad of problems that we have on terrestrial mining, right? And yet most terrestrial mining programs don't account for these issues that inevitably come up in them.
Yeah, and it's all because the experience that the school has had. The School of Mines is a widely respected school that has been looking at all these issues. How to not just identify it and excavate and extract the resources, but all of the socioeconomic and legal aspects of this is the environmental component. How to do it responsible, how to do it sustainable, in a sustainable way. And so for us, it was just a normal extension. In fact, we just went to every department of the school to enroll the help from faculty, and they didn't have any problem. I mean, we talked with mineral economics, the people at mechanical engineering, robotics, people from geology, geophysics, petroleum. All of them play a role. In fact, every department is involved, and we're just doing it beyond Earth. But you're doing the same thing. It's the same type of issues, economic issues, technical, legal, environmental, the same thing you're going to have to deal beyond Earth.
Yeah, that's hard. I mean, in a lot of ways, I think your program is the culmination of what we have learned mining on Earth. It is a culmination of all the problems and all the issues and all the disciplines that are somewhat involved in terrestrial mining, and yet ironically, you're creating the program for space. So we are taking our understanding here and starting... And so the space mining is starting in its first step with all the issues that we already know about terrestrial mining. So we should be better at doing space mining, you would think.
You hit a really good point here. One of the only things that are different between our space resources program and the terrestrial resources ones is that you introduce space, obviously. So you have to teach about transportation in space, rockets, how to get to point A to point B. Here on Earth, it will be trucking from one place to another.
Correct, yeah.
Here is a different, you use different fuel to get there. You have to introduce the geology of different places, but it's the same approach that you follow. But you hit on a point that it's important in terms of what have we learned from doing it on Earth that we should do differently when we go to space. Mm-hmm. We are positioned at a very unique time in history in which we're starting from scratch. That didn't happen on Earth. On Earth, we just went around and just looking for first survival, just water and food wherever we could find them. We bump into how to make tools and then agriculture. Eventually, we learned how to do metallurgy and work with metals. At some point in the Industrial Revolution, we hit oil and we started using it. But along with that we went about in a very prepared way. And in fact, a lot of good things came from that and a lot of not so good things. I mean, there was entire civilizations that were affected by this process.
I guess that's a really important point, is that some of the legacy issues of terrestrial mining are because we didn't have the benefit of hindsight. We tried these things and then realized, actually, they didn't work out that great. Yeah,
exactly. But in the process, we did a lot of bad things to human beings and to the environment.
Mm-hmm.
So we are positioned in a very unique point in which, okay, let's start from scratch. First of all, look at the resources that there are there. How much is there? How much is that we can use? Let's do it in a way that it can benefit humankind, or at least there's a fair way to get there. Go through all the legal issues that will give an opportunity to all countries to get involved. Even though you may not think about environmental issues in space, there are environmental issues because you're going to be using resources that are not renewable. I mean, the water. So how much are we going to use? How much is there? How are we going to extract it so that everybody has a chance to do this? There's issues if you're going to go to an asteroid and you're going to bring it closer to Earth. Well, you don't want to get it too close. So there's things that are going to have to be discussed at the international level. Countries as a whole will have to decide how to do this. There's going to be regulation. You may not want to over-regulate at first because you want to get this going, but at some point, you're going to have this so that all countries have access to this. So again, we're starting with millennia of knowledge on this. Might as well do it right this time.
So do you think, is that one of the biggest challenges in space exploration, is the fact that you have to have that agreement between this global community before you do? The obvious problem that you encounter when you go and do space exploration is who owns the resources, who extracts it, to whose benefit are they being extracted, who enjoys the benefit as well. There's some kind of fundamental issues that you run into in that sense.
It's just like on Earth. To go from a resource, that means knowing that something probably could be useful, to a reserve, that that you can go after it. To go from a resource to a reserve, you need geological, technical, scientific, economic, legal, environmental certainty that you can go after that so that you can invest. If not, a company will never touch it if they don't have all that certainty. Mm-hmm. So if you're now looking at resources in space, not only you got to have the geological certainty, okay, it's there. The economic certainty, who's going to purchase this? Who's going to be the customer?
Yeah, who's going to finance this?
Right. And you got to have the legal certainty, because even though you say, okay, the resource is there are companies willing to buy it, can I touch it? And legally, and right now from what we have, in 1967, right at the time where there was just the Soviet Union and the U.S. trying to get to the moon, the whole world got together and put together a very unique document called the Outer Space Treaty. And it was signed by more than 100 countries, in which everybody agreed that no country can own any celestial body. You cannot own the moon. You cannot own an asteroid. You cannot militarize the use of space. This was at a time in which space looked so far away that everybody signed on to it. Then there was the Moon Treaty in 1979, which got a little bit more specific, and less than 20 countries signed it. Australia being one of those, by the way, because people started seeing, well, maybe there's more to space than we thought. And none of the spacefaring nations signed it. No China, no US, no Russia. And so now we are up against a treaty that tells you that you cannot own the place. But the question is, I don't want to own it. I just want to have claim to a certain place where I can extract the resources and then leave. Well, it's not that easy. And so along with technical issues, you have a whole movement now, a legal movement looking into this. The Netherlands took a leadership role. They signed both treaties, and they put together the Hague Space Resources Working Group that brought different countries to start defining how is that we going to extract resources. Can we not get around, but how to still fulfill the obligations of the treaties, but be able to identify the resource, to claim extract them, also establish very basic things like how far away are the operations, who does it, how can you do it in such a way that you don't harm the others, and how much can we actually extract. So these are things that are discussed right now, and they're being elevated at some point to some international forum so that companies can have legal certainty that they can go after it.
Yeah, that's right. And I guess the other challenge here is that because space is such a onerous endeavor, that you're going to have private companies, you're going to have countries, you're going to have political organizations that are going to have a say. You probably will have global treaties that will dictate things. So there will be the challenge there. And then you made the point that can't overregulate it, because then we're going to force everyone to walk one path, which may not be the best thing. So you do want to have people do different things to see which path wins. And that's kind of the natural way of figuring out.
You again touch on a very important point. You hit one that is very unique. So you call it onerous activity. So far, space has been this place that somehow is separated from Earth. It's this lofty thing where we go out, this romantic view of space, where all these things that happen over there are fascinating to us. And this has been a result of 60 years of scientific exploration. And science, no matter what you do here on Earth or in space, has this feeling of knowledge, of something that is not touched by human behavior in a way, that it occurs on a vacuum, literally. So far, it has been about finding subsurface oceans in Europa and the possibility of life in some other places, of this Pluto, this fascinating object way out there in the solar system, but with no relationship to profit or to legal issues. It's been away from the hands of lawyers and business people. But as you introduce resources, which at some point you're going to have to introduce because that's going to allow it to even travel further and do more exploration and learn even more, now you start talking about human behavior. We're exporting the same things we do on Earth and do in space. And that's, some people see it as contaminating space in a way. Yep. But if you think about it, space exploration is a human activity. Mm-hmm. Yes, all these things occur in the universe, but we are the ones interpreting. We are the ones giving them a scientific understanding. And along with that, we're going to bring everything that we do on Earth. And yes, it's going to be different. Now we're going to be talking about companies doing things, and whether we like it or not, it's going to happen. And we just have to do it in the right way.
Yeah, but it's an interesting kind of social, I think, problem that you kind of identify, that, when you do things for science, it's considered to be a lot purer. Even on Earth, right? Like Darwin sailing around the world trying to develop the origin of the species, like his theory about natural selection, that's considered pure. But if you have a company going out to try to somewhat exploit the same areas that he went to, it's like that seems to be has a different social subtext to it than the fact that it was just done for science. It was just done for knowledge. So the pursuit of knowledge is pure. The pursuit of some benefit, some economic benefit.
But that has happened in every scientific field. It starts with this lofty goal of learning, and that's what science is about. This happened to, like you said, Darwin, and then what happened we started pursuing nuclear science. It was fantastic to look into the inner workings of the atom, and eventually these became nuclear power stations and nuclear bombs. And the same happened with the laser, that started as this very fascinating interplay between molecules and all of that. And now it's in every supermarket. And so eventually science gives you the tool to understand nature, so then you can apply it. No matter what, in every human activity, it's going to end up seeing how is that it can benefit, how is that we can utilize it. How it can be done right or wrong, that's something else. But eventually, every scientific endeavor is going to result on an applied use of nature.
Yeah, an applied application to it.
Right.
I'm talking on the behalf of a lot of people here, but in my head, the social problem really comes from the fact that there's winners and losers out of the application of that science. And I think that's where... So it'd be interesting to see how we as a global community navigate that, where when we do go into space, how do we make sure that there isn't this perhaps disparity between the significant winners and the significant losers, and how, like, do we do that well? Do we not do that well? Or
and that is a very legitimate question. Who's going to be, in a way, even the commercial use of space has been far-reaching. It includes everybody. Everybody can pull a phone and look for the directions, and they're using this system up there that it looks like it's for everybody. And yes, companies are earning money doing this, but it's accessible to all of us. We all use communications. We all look at the weather forecasting. We all use GPS. And so in a way, even the commercial application, the commercial use of space right now, it reaches everybody.
It is very democratized.
That's right. It's very democratized. So once we start using resources, the tendency will be somehow the same way. The resources are going to use us probably to give us even better communications, or allow us to probably have a settlement on the moon that will help all of us, maybe even beam solar energy from space that we can all use here and have plenty of energy. But it's up to us to do something like that. It's going to be tricky because who's going to own the resources? Who's going to have access to them? Who's going to use them? Probably some of the countries that can have access to it will do that. Yeah. And so that's the question actually that is coming just right now, along with the legal aspects. There's a socioeconomic workshop being conducted everywhere. And so for developing countries, for the first time, for some of them, they feel that they can have access to doing something in space. Mm-hmm. They may not have the rockets or the probes to go places, but they may have the experience on mining or resource extraction, that all of a sudden they have a lot to offer to other countries that may want to utilize. So this is a way for other countries that have not worked in space to come and actually do it. Obviously, you just have to make it in such a way that they don't feel that they're going to be exploited again. A lot of them happened with a lot of them. They have the resources. Other civilizations came along and they used them. They want to know how is that they can get involved, but be part of it, not just being used.
Yeah, and I think it goes back to your point that because of the lessons that we've learned, we have the opportunity to be a lot more sophisticated in setting up the architecture of how we go about it. Yeah, and I think that's perhaps a difference to, again, it took us 1,000 years to figure out how to do this well, and now we have the opportunity to at least start off in a better position and then go forward. I mean, inevitably, the pessimist in me thinks that there will still be conflict, I think, because it is a fertile space for conflict. And you made the kind of point that a lot of the timing of it, I think, kind of becomes really important. The first person goes out there and kind of finds the water in the easiest places and does something with it and exploits that resource completely to a point where there's none left for someone else that's coming next. That, I think, will then create this kind of source of conflict.
Absolutely, and there's concern about that. I mean, we humans have done that throughout all our history. And yes, we have now organizations like the United Nations or international groups that are looking after doing things right in many ways, climate change and all that. But even there, I mean, you see that there's disagreements, even though the whole world is trying to do this in a very organized, united way. Mm-hmm. Climate change affects all of us, and that's why we all have to be involved. Yeah. Space will be affecting all of us. We all going to have to be involved in decisions, and if somebody does something that is not according to international standards, how is that we going to enforce this? How are we going to regulate it? How are we going to be able to keep that agreement that we have among all of us? And we are in a good position, like I said, after thousands of years of doing this, but still humans are humans.
Yeah, that's right.
And things like this are going to happen. Let's hope that we can control it.
The last point that I really want to talk about in that sense is the point that you make about like climate change and things like that. I think in my head, it is inevitable that we will go to space to find resources, because I think that if we continue the trend that we're doing in society right now, where we are putting a higher premium on environmental preservation, it means that at some point we are going to try to find resources off this planet. So would you agree with that notion, that I think that us going to space is inevitable because at some point the economic premium or the cost that comes to environmental degradation would be too much to keep working on Earth? I mean, like, for example, we're not going and exploring in the oceans. I think that's because we have this notion of how much we have somewhat destroyed land. We definitely don't want to destroy the ocean to that.
Yes. In fact, space mining has been compared a lot with ocean mining because of the difficulty. They post that underwater mining is extremely difficult. I mean, you're dealing with water at high pressures. The problem is that the moment you start doing it, the environmental effects are going to be quite drastic. And you have living creatures on the ocean, and the moment you start drilling, you're going to have problems. Yeah. Space mining may not have that, But then there will be other considerations. At least it doesn't have the living part. But who knows? If you go to Mars and you start extracting the water and all of a sudden you find that there's life, where do you stop? Do you say, okay, don't touch it. Let's figure out what type of microorganisms are this. There's going to be a lot of that talk. So it's going to happen no matter where. But you were making the point of, are we going to say, well, it's enough mining on Earth?
In my head, I think there will come a point where we will value the environment on Earth far more than the economic benefit that we get out of extracting the resources in exchange for that.
Because in a way, taking care of the environment is an economic issue. I mean, if we are destroying ourselves, it's all about survival of the human species. It's all about us in this planet. Even though we do things in space, it's all about humans on this planet. And so, yes, right now it doesn't make economic sense to go out and get all the iron and nickel and gold and bring it to Earth, because we still have plenty of that here. But we can foresee a point decades and decades from now in which we're starting to drill too deep. We're using a lot of energy in doing this. We're causing major environmental degradation. And at that point, the cost of the product is going to be such that we may have the infrastructure already in space ready to say it makes economic sense to bring it. The economic case brings also, the environmental aspect. The product is going to be so expensive because we're causing a lot of environmental degradation. And in fact, already mining companies are doing a lot to preserve the environment, and that's why the operations may get costly as time goes by. Yep. And so at that point, when this is the opinion of Jeff Bezos, that he thinks at some point having Earth just as a residential zone, and all the industry goes into space and you bring it from there. Yep. That's far out there. I wouldn't be able to see it, but maybe we'll get to that point.
Yeah, that's right. I mean, I think if we start valuing different things, you can see that maybe we will look at alternative methods of going, well, maybe we don't want to mine iron on Earth anymore. We want to get it. We don't want to mine mountains in Australia trying to get iron out of them, right? We want to send this somewhere else.
Yeah, if you go to an asteroid, it's a rock that you don't even see. So there's millions of them. So if only one asteroid can provide all the platinum that we have ever mined and we will ever mine on Earth,
yeah, let's
go after it. Yeah, why not? Actually, let's do it even before it comes and hit us. So.
Yeah, that's right. So we're getting towards the end of our interview, and we always end our interview with two questions, which I'll slightly modify for you. So the first question is, so when it comes to space exploration and space in general, let's just say that, what is something, an idea, a concept, a behavior that you think needs to die, that we need to get rid of, that people shouldn't do anymore?
Yes, that's a good question too. I give a lot of talks to the general public, and the moment they hear the word mining or extracting resources in space, they tend to think negatively because of what we have done on Earth. So a lot of people will say, we've done it on Earth. Why do you want to do it in space? Why do we want to ruin space? And the way we should look at this is that the resources in space will give us an opportunity to conserve the ones that we have here on Earth. In fact, it gives us more opportunities. And so let's not look at it as a negative way. In fact, mining on Earth is not all that bad. I mean, it gives us a lot of the things that we use. We just have to do it right. Yeah. And the other thing that comes out is, why spoil space from just pure science and now look at it from the point of view of utilizing it? Because when we do that, it will give us a chance to know even more about space, and it will benefit us all in here. And in fact, I always like to point out that, yes, we mentioned a lot of resources, platinum and water and gases and oxygen and all that. There's one resource that is very important and is seldom mentioned, and that is inspiration. I mean, space has a way to excite the young and the old, to unite all sorts of ideologies, countries, political views. It inspires us. And inspiration, it's a renewable resource. So might as well use it wisely as we start looking at how is that we can better utilize the resources in space to benefit all of us here on Earth by keeping that inspiration that space gives us to all of us.
I think that's a great point. So I said there were two questions. So the first one is, what is something that you think we need to kill? And the second one is, what is something that we need to maintain? And I think you just answered that
You got it.
Excellent. That's a perfect spot to end on. Thanks a lot for joining us, Angel. It was great.
Thank you, Ahmed. It's been a pleasure.
This episode of Exploration Radio was brought to you by Ahmad Salim and Steve Beresford, produced by Sean Jeffrey, edited by Humayun Mir, and recorded live in Perth in late 2019. Exploration Radio is supported by the AIG, the Australian Institute of Geoscientists, the MCA, the Minerals Council of Australia, the Society of Economic Geologists, 121 Group, and the Assay. And we are the official media partner of the 2022 PDAC conference. Until next time, let's keep exploring.